Dear students, today we are going to discuss Module 4 Digital Signal Processing, Design of IIR Filter. Under this module, we are going to discuss realization of IIR filter, or we can say implementation of IIR filter. Realization of IIR filter. We know that IIR filters are the recursive filters. That is, IIR means infinite impulse response. Okay, so it has both A coefficients as well as B coefficients, and the convolution formula for IIR system will be given by y of n equal to summation k equal to 0 to infinity h of k x of n minus k. Okay, and here this represents it consists of IR filter consists of present and all past input samples. Okay, means nothing but this IIR filter is having infinite memory. Okay, the IIR filter is having infinite memory, and here the system output, the IIR filter, the IIR system output will be represented as y of n, and the input will be represented as x of n, and your past outputs, the past outputs will be represented as y of n minus 1, y of n minus 2, etc., and the past input will be represented as x of n minus 1, x of n minus 2, and the present input will be represented as x of n, and the present output will be represented as y of n. Okay, and next, your recursive system, okay, your recursive system y of n consists of both past as well as present as well as both input as well as output. Okay, and here how we are going to represent the transfer function of the IIR system. Okay, generally already we have discussed the digital filters can be represented by difference equation, differential equation. I have discussed. Okay, so here how the generally the difference equation, the IIR system will be described by the differential equation, that is y of n equal to minus summation k equal to 1 to n ak y of n minus k plus k equal to 0 to m bk x of n minus n. Actually, where m and n are the poles and zeros. Okay, where m and n are the poles and zeros, that is number of poles and number of zeros. Okay, and a are the a is the a coefficient and b coefficient. This b coefficient is nothing but your numerator coefficients, and a coefficients is nothing but your denominator coefficients. All the b coefficients are zeros, all the a coefficients are poles. If you apply z transform for the above equation, difference equation, then y of z plus summation k equal to 1 to n ak z power minus k y of z equal to summation k equal to 0 to m bk z power minus k z of k. So here, in order to simplify, here if you take the y outside, then you will get this is y of z divided by x of z. This is your system function of your IIR filter. Okay, system function or transfer function of your IIR filter. You can represent system function or transfer function of your IIR filter. Now the system function of IIR filter h of z will be given by summation k equal to 0 to m bk z power minus k whole divided by 1 plus summation k equal to 1 to n ak z power minus k. I already told that this b is your zeros and a is your poles. It consists of both numerator and denominator, so that it is called as a recursive filter. Now we are having different type of structures to realize the IIR filter: direct form 1, direct form 2, transpose form structure, cascade form structure, parallel form structure, lattice structure, and ladder structure. Why we are going for a different structure means in order to save the memory. Okay, so each and every structure will have some advantage. In order to overcome the advantages of each structure, we are going for the next structure. For example, if you take direct form 1 structure, here you are having more number, it needs more number of delay elements to compute the problem. Okay, so that we are going for direct form 2. So here somewhat the delay elements will be reduced. when compared to direct form 2, the delay elements and number of multiplies will be reduced in transforms form. So that only we are going for the different types of structures to implement the IIR filter. Okay, direct form 1 realization of IIR is nothing but the direct implementation of the difference equation or transfer function. It is simplest and most straightforward realization. It is nothing but your direct form 1 structure. Now the difference equation will be given like this, and we are going to split the equation y of n equal to minus a1 y of n minus 1 minus a2 y of n minus 2 etc. minus an y of n minus n plus b naught x of n plus b1 x of n minus 1 plus bm x of n minus m. Okay, so like that we need to simplify. So and what we are going to do here, W of n means we are going to split the A coefficients and B coefficients. We are going to take all the A coefficients will be is equal to, all the B coefficients will be named as W of Z. After taking Z transform for this equation, you will get W of n equal to summation k equal to 0 to m bk x of n minus k is equal to b naught x of n plus b1 x of n minus 1 plus etc. bm x of n minus m. Now this y of z is your final output. It consists of both a plus b. So b is nothing but your omega of n. That's why it is represented like this. Now direct form 2 structure. Direct form 2 structure is the alternative structure to direct form 1. It is more advantageous when compared to direct form 1. I already told that it is using lesser number of delay elements than direct form 1. Okay, so same thing here, also same thing, but here only thing is same. We are here also we are going to split the y of n will be splitted into minus a1 y of n minus 1 minus a2 y of n minus 2 minus a3 y of n minus 3 minus an y of n minus n. And only thing is what we are going to do here, we are going to split into 2. So that is the b naught b1 will be, we are going to split it as y of z divided by w of z and into w of z divided by x of z. So w of z divided by x of z is nothing but 1 divided by 1 plus a1 z minus 1 plus a2 z minus 2 plus etc. an z power minus n. And y of z divided by w of z is the numerator equation. And we are going to first for this one we are going to implement direct form 1 and we are going to implement direct form 2 1 and then we are going to do direct form 2. Okay, and cross multiplying this equation you will get w of z will be is equal to a1 z power minus 1 omega of z plus a2 z power minus 2 omega of z plus etc. an z power minus n omega of z equal to x of z. Now y of z will be is equal to b naught w of z plus b1 z power minus 1 w of z plus b2 z power minus 2 w of z plus etc. bm z power minus m w of z. So what is the difference between direct form 1 and direct form 2? Means it uses separate delays for each and every input. Here common delays will be used for each and every input. And here for m minus 1th order IIR filter, direct form requires m plus n minus 1 multipliers and m plus n minus 1 adders, m plus n minus 1 delays. But all this will be reduced here. It needs only maximum of m minus 1, n minus 1 delays. Delays will be reduced in direct form 2. It is a non-canonical structure because it requires more delays. It is a canonical structure because it requires less delays. It is more efficient, it is less efficient. Here direct form 1 can be viewed as two linear invariant time systems in cascade, but here it will be viewed as a only single invariant systems. The first one is recursive and the second one is non-recursive. Here both are here first one is non-recursive and second one is recursive. Recursive means I already told that the first one is not having feedback, the second one is having feedback. But in direct form 2, the first one is having feedback and the second one is not having feedback. This is the difference between direct form 1 and direct form 2. Okay, thank you students.